Hi students, in this session we are going to discuss about the last chapter in mathematics, that is probability. As you know, this chapter is very simple and without taking much effort you can score full marks from this chapter. Okay, now let us understand some terms that we use in probability. Let us take some examples and understand these terms. First term that we are going to discuss is sure event or certain event. Let us see what is a sure event. You are familiar with a die. How many faces a die has? You know, it has 6 faces and the numbers marked on the faces of die that are 1, 2, 3, 4, 5 and 6. You know that. Now the question is, what is the probability of getting a number less than 7 when a die is thrown? You know that when a die is thrown, it shows one number, one face up always, and you know that that will be always less than 7. It can be either 1, 2, 3, 4, 5 or 6. So what is the probability of getting a number less than 7 when a die is thrown? That is 1, because always you will be getting a number less than 7. So such events are called sure event or certain event. So here for a sure event, the probability of event will be 1. PE stands for probability of an event, that will be always 1. The second term is impossible event. I will give you another example. You see, what is the probability of getting a number 8 when a die is thrown? You know that a die has number from 1 to 6, there is no 8. So what is the probability of getting 8 when a die is thrown? 0. Why? Because it is impossible event. It is not possible to get a number 8 when a die is thrown. So this type of events are called impossible event. So what is the probability of an impossible event? That is equal to 0. So probability of a sure event, that is 1. Probability of an impossible event, that is 0. Now I will give you one more example. Suppose it is rainy season. It is cloudy also. Now what will be the probability? If someone asks you what is the probability of getting rain today, we can say that it may be 60%, 80%, 90%, etc. You see, here what do you mean by 80%? 80% means 0.80. 80% means 80 divided by 100, 0.80. 60% means 60 divided by 100, that is 0.60. That means probability of an event that can be, we have seen, that can be 1, that can be 0, because 1 in sure event, 0 in impossible event, and in this situation the probability of an event can be in between 0 and 1. So probability of an event that can be greater than 0 or equal to 0, or probability of an event can be less than 1 or equal to 1. Is it clear? So probability of an event PE that lies between 0 and 1. It can be equal to 0 or greater than 0. It can be less than 1 or equal to 1. Now the next term that we are going to discuss is equally likely outcomes. Equally likely. Okay, equally likely outcomes. Suppose you are, let us take the example of tossing a coin. When you toss a coin, what are the two possibilities? The first possibility is when you toss a coin, you will be getting a head or you will be getting a tail. There is no other options. Okay. And why it is called tossing a coin is called an equally likely outcome? Why? Because here both head and tail have the same possibility of showing up. Clear? Either it will be tail or it will be head. The possibility of getting tail and head, they are equal. That's why these are called equally likely outcomes. Another example, throwing a die. When you throw a die, you may get 1, 2, 3, 4, 5 or 6. The probability or the possibility of getting all these numbers are same or are equal. That's why tossing a coin and throwing a die is called an equally likely outcomes. Clear? In a family, a child is born. Here, this situation, it is equally likely outcome. Why? Because It can be either a boy or it can be a girl. Okay, so it is also an example of equally likely outcome. So how can you define probability of an event? Probability of an event can be defined as number of outcomes favorable to event divided by number of all possible outcome of experiment. You have to keep this in mind. Okay, it's very important. Probability of an event equals probability or the number of outcomes of favorable event divided by number of all possible outcomes. Let us take one example and let us understand how to find the probability of an event. Okay, let us read the question now. A bag contains a red ball, a blue ball and a yellow ball. So, how many balls are there? 3 balls are there. One red, one blue, one yellow. All the balls being of the same size. It has same size. Okay. Kritika takes out a ball from the bag without looking into it. What is the probability that she takes out the yellow ball? You have to find then red ball, blue ball. You see how many balls are there? There are 3 balls. So 3 balls, this 3 is known as the denominator in the explanation or the definition of probability of an event. That is number of all possible outcomes. So how many balls are there in the bag? There are 3 balls. That is the number of possible outcomes, that is 3. Now the question is, you have to find the probability of yellow ball. You see how many yellow balls are there? There is only one yellow ball. So what is the probability of getting an yellow ball? Probability of getting yellow ball equals number of outcomes favorable to event, that is one yellow ball is there, divided by number of all possible outcomes. There are 3 balls. So 1 ball out of 3. So the probability of getting yellow ball is 1 by 3. Similarly, can you tell me what is the probability of getting red ball? How many red balls are there in the bag? 1 red ball. Total number of balls? 3. So what is the probability of red ball? 1 by 3. Now, how many blue balls are there? 1 blue ball. Total number of balls in the bag? 3. So what is the probability of getting a blue ball? That is 1 by 3. So here, probability of getting yellow ball is 1 by 3, red ball is 1 by 3 and blue ball is also 1 by 3. Now let us just add all these individual probabilities. Probability of yellow ball plus probability of red ball plus probability of blue balls. That will give you 1 by 3 plus 1 by 3 plus 1 by 3, that is 3 by 3, that is 1. From this, what do we conclude? We conclude that sum of the probabilities of all elementary events of an experiment is equal to 1. Now let us take the example of probability of getting an yellow ball. Okay, what is Py, probability of getting yellow ball? Py equals 1 by 3, we know that. Now, can you tell me probability of not getting yellow ball? That is y dash, it is denoted as y dash. Okay, what is the probability of not getting yellow ball? Not y. Not y means that will be red or blue. You see how many balls are there? 3 types of balls are there. 3 types are yellow, red and blue. The question is, what is the probability of not getting yellow? That means probability of getting red and blue. Okay, now that is 1 by 3 plus 1 by 3, that is 2 by 3. The same you can find out using another method. The probability of not getting yellow ball equals 1 minus probability of getting yellow ball. Clear? Probability not y equals 1 minus probability of y. You see, 1 minus probability of y. What is probability of y? 1 by 3. 1 minus 1 by 3, that is 2 by 3. In either case condition, you will be getting the same answer. Okay, so from this, in general, we conclude that probability of not an event, E bar, probability of E bar, that is probability of not an event equals 1 minus probability of an event E. Okay, probability not E equals 1 minus probability of E. From this, we conclude that probability of an event E and probability of event not E, they are complementary. Complementary means when you add these two, you will be getting 1. Probability of event plus probability of not event equals 1. Now let us discuss what happens or what are the possible outcomes when a single coin is tossed. Here you know that when a coin is tossed, the probabilities or the possibilities are, it can be either a head or a tail. So there are two possible outcomes. How can you get these two possible outcomes? Using the formula 2 raised to n, that is 2 raised to 1 here. You see, a coin has two sides, head or tail. How many times you have, how many coins you have tossed here? You have tossed one coin. So 2 raised to 1, that equals 2. So there will be two possible outcomes, that is head or tail. Now if you take two coins and if you are tossed, you take two coins and you toss it. Here you may get head, here you may get tail. Here you may get head, here also head. Here tail, here tail. Here tail, here head. So how many possibilities are there? The possibilities are 2 raised to 2. That is because here you have taken two coins. So total number of possible outcomes, that is 2 raised to 2, that is 4. What are they? They are head head, head tail, tail head, tail tail. I think it is clear. You see, in the first coin you may get head, the second coin also may show head. The second chance is, the first is head, the second is tail. The third one, the first one is tail, the second one is head. And the fourth one, both are tail. So how many possibilities are there? There are 4 possibilities. Now let us see what are the possibilities when you toss 3 coins. You have taken 3 coins. Your 3 coins are tossed simultaneously. So the first coin may show head, the second head, third also head. First tail, second tail, third one also tail. Here head, tail, tail, head, head, tail. You see, there are how many possibilities are there? Outcomes are there. The total number of outcomes is 2 raised to 3, that is 8 outcomes are there. And we have depicted all the 8 or outcomes here. You see, head, 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 tail, head, tail, head, head, tail, tail. Can you by heart this? No, it is not easy to by heart this, but there is a trick. You see, here total number of outcomes, that is 8. You know that there are 8 outcomes. The first column you write first 4H together, H, 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 H. You have taken 4H and written, and then you take next 4 tails, tail, 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 tail. You see, the first column, that is over. Head, 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 tail, 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 tail. Now the second column, what you have to do? First you have to take 2 head, 2 tail, 2 head, 2 tail. You see, the last one you should write alternate, head, tail, head, tail, head, tail, and you will be getting the sample space as shown here. So this representation is known as sample space. Okay, I think you understood how to write the sample space. Now you see, I think it will be easy for you when 2 coins are tossed. What you have to do? How many possibilities are there? 4 possibilities are there. So how can you write it? First you write 2 head, 2 tail. Then head, tail, head, tail. The third case, when 3 coins are taken, what you have to do? Head, 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 tail, 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 tail. 4 heads together, 4 tails together. Then 2 heads, 2 tail, 2 heads, 2 tail, like that. The final column, head, tail, head, tail, head, tail, etc. Now it is very important. Now let me ask you one question. 3 coins are tossed simultaneously. What is the probability of getting 1 head? What is the probability of getting exactly 1 head? Let us look at the first row. 3 head is there, that is not possible. The question is the probability of getting exactly 1 head. Okay, so the first row it is not possible, second one is not possible, third one not possible, yes, fourth one is possible. Why? Because head, tail, tail. So there is only 1 head in that row. So that is possible. So there is only 1 head. Then next one, 2 head. Yes, next one also there is, sixth one there is only 1 head. So 2. Then seventh one also there is only 1 head. And last one there is 3 tail. So what is the probability of getting 3, at least 1 head when 3 coins are tossed? When 3 coins are tossed, these are the sample space. From the sample space, you can understand that the probability of getting exactly 1 head is 3 by 8. In 3 cases, in 3 rows, you will be getting only 1 head. Total probability of getting exactly 1 head is 3 by 8. Now the next one, what is the probability of getting 2 tail? Can you tell me? When 3 coins are tossed, what is the probability of getting 2 tail? The first row is not possible. Second, not possible. Third, not possible. Fourth one is possible because 2 tail is there. Then what about the fifth one? Not possible. Sixth one is possible. Seventh one is possible. So how many are there? There are 3. So what's the probability of getting 2 tails when 3 coins are tossed simultaneously? 3 by 8. Now let us discuss about dice. You might have seen die. Okay. So a die has 6 faces and numbers marked from 1 to 6. Now when a die is thrown, what are the possible outcomes? The possible outcomes are 1. When you throw a die, either 1 will come up, or it will show 2, or 3, 4, 5 or 6. So when a die is thrown, the possible outcomes are 1, 2, 3, 4, 5 and 6. So there will be 6 possible outcomes. 6 raised to 1. A die has 6 faces, you have thrown it once. So 6 raised to 1, there will be total 6 outcomes. Now if you take 2 dice, how many outcomes will be there? If you throw 2 dice together, the total number of outcomes will be 6 raised to 2, that is 6 square, that is 36 will be there. Outcomes will be there. Let us write the outcomes now. The outcomes will be 1, 1. That means the first die will show 1. The second one will also show 1. In the second row, the first die again shows 1. The second one shows 2. So 1, 1 is over. Now it can be 1, 2. It can be 1, 3, 1, 4, 1, 5, 1, 6. Or it can be 2, 1, 2, 2, 2, 3, etc. Now you will be getting a sample space as shown here. You see, from 1, 1 to 6, 6. How many are there? There are 36 possibilities. Now you have to learn this sample space also. Why? Because for your examination, questions will be there from this topic. Okay. Now let me ask you one question. What is the probability of getting a sum of 10 on both dice when 2 dice are thrown? You see, you throw 2 dice. The question is, what is the probability of getting a sum 10 on 2 dice? The numbers that appear on the top of 2 dice, when you add, you should get 10. What is the probability of getting 10? That's the question. You see, look at the sample space where you are getting a sum 10. You see, in the first row, you won't get 10 because the maximum 1 plus 6 is 7 there. In the second row, 8 is there. Maximum. Third row is not possible. In the fourth row, there is possible. You will be getting 10 when on the first die, 4 appears and 6 appears on the second die. See, 4, 6. When you add 4 plus 6, you will be getting 10. So that's the first case. Now the fifth row, 5, 5. You will be getting 10 there. Then there in the fifth row, no other, sum gives you 10. Then the last row, 6, 4 is there. You see, 6, 4. The first die, 6 comes. The second die, 4 comes. What is the sum? 10. So in 3 cases, you will be getting a sum 10 on 2 dice. See, I think it is clear to you. The possibility, the favorable outcomes are 4, 6. The sum is 10. 5, 5. Sum is 10. 6, 4. The sum is 10. So what is the probability of getting a sum 10 when 2 dice are thrown simultaneously? The probability is 3 by 36. I think it is clear to you. Now let us see what is the probability of getting a doublet when 2 dice are thrown simultaneously. Doublet means 1, 1 is a doublet. The same number you should get on 2 dice. That's the meaning of doublet. 1, 1 is a doublet. 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So how many doublets are there? 6 doublets are there. So what's the probability of getting a doublet? 6 by 36. That is 1 by 6. Now we will discuss about playing cards. You might have seen playing cards. Can you tell me how many playing cards will be there in a deck? In a deck of cards, there will be 52 playing cards. These 52 playing cards are divided into 4 suits, namely spades, clubs, hearts and diamonds. So 52 playing cards are there, and these 52 playing cards are divided into 4 suits, namely spades, clubs, hearts and diamonds. You see, what's the color of spade? It is black in color. What is club? What's the color of clubs? That's also black. What about the color of hearts and diamonds? They are red in color. Now let us see what are the cards that includes in the suit spades. First of all, there will be an ace, then card number 2, 3, 4, 5, 6, 7, 8, 9, 10, then comes jack, queen and king. So total how many are there? There are 13 cards in spades, starting with ace, then 2, 3, 4, 5, 6, 7, 8, 9, 10, then comes jack, that is represented as J, queen, that is Q, king, that is K. So together 13 cards are there. Similarly, in clubs, let us see what are the cards. The same cards are there in clubs also. That is ace, that is A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. So total how many are there? 13. Now in hearts, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, that is J, Q, K. Total 13. Similarly, in diamonds also there are 13 cards. So total how many cards are there? 13 plus 13 plus 13 plus 13. 4 13s are there. That is 52. So there is a total of 52 cards in a deck of playing cards. So these 52 cards are divided into 4 suits: spades, clubs, hearts and diamonds. How many are blacks out of this 52? 13 plus 13. 26 are black and 26 are red in color. So black, there are 26 black cards and 26 red cards. Now you see, you can see JQK, that is jack, queen and king. They are known as face cards. What are they called? Face cards. Now in spade you have 3 face cards. In clubs you have 3 face cards. In hearts and diamond, in all the suits you have 3 face cards each. So what's the total number of face cards? Total number of face cards is 12. These are the basic things that you should know about the playing cards. 52 cards divided into 4 suits, 26 black and 26 red. Black includes spades and clubs, 13 plus 13. Red includes hearts and diamonds, 13 plus 13, 26. Now I will ask you a question. In a deck of playing cards, what is the probability of getting a face card? What is the probability of getting a face card? You see, total 52 cards are there. How many face cards are there? 12 face cards. So what's the probability of getting a face card? 12 divided by 52. Now what's the probability of getting an ace from a deck of playing cards? How many aces are there? 4 aces are there. So what's the probability of getting ace from a deck of 52 playing cards? 4 by 52. Now one more question. What's the probability of getting a jack of red color? Question is clear to you. What is the probability of getting a jack of red color? How many jack are there with red color? There are 2 jacks. You see, hearts and diamond. So 2 jacks with red color. So what is the probability of getting a red color jack? 2 divided by 52. I think it is clear to you. What is the probability of getting a queen? How many queens are there? 4 queens. So what is the probability of getting a queen? 4 by 52. I think the basic is clear to you. Now we will discuss about these topics in details when we discuss about previous year's questions and NCERT solutions.